Okay, first thing we're going to do today is our SAT warm-up. Go ahead and press pause until you are ready to check your answers. When you're ready to check your answers, press play. Okay, let's take a look at these. If we took these two, these are compound inequalities. Look a little weird, but we've been working with ones that were very similar. And if we take the second one and stack it over top of the first one and add them together like it's a system of equations, what you're going to notice is the y's cancel. And we're left with 6 plus 4 is 10, x plus x is 2x, 13 plus 9 is 22. And then if we divide each of these by 2, we get our solution, which is choice C. Now choice D, on all of these, the radius is the base. And formula for the area of the triangle is area equals 1/2 the base times the height. And since all of this is the same on everything, all we have to do is find the one that has the greatest height, or the highest point, which is choice D. So that gives us, letter D, which is triangle AOD. Finally, for this one, if the area of the circle is 16 pi, and we know area equals pi r squared, then the radius of that circle would have to be 4. If the radius is 4, then we would double it to find the diameter, which is the same as the side of the square. So if this is 8, this is 8, this is a special right triangle. It's the 45, 45, 90. So the hypotenuse would be 8 times the square root of 2. That's how we get the diagonal of the square, which is the hypotenuse of that right triangle. So now finally we find the difference in those two. So 8 roots of 2 minus 8 is about 3.31. So choice B would be the correct answer. Okay, go ahead and pull out your homework. I'll be coming by to check it while you are making corrections in red ink. All right, so let's take a look at the homework. The first 3 were fairly straightforward. This one was a little weird, I'll give you, because it's at 1/2, but we would still just go up to over 3 and it wouldn't be terrible to draw. So take a look at 6, 7, 8. You can hit pause if you need to. If you have questions for me, be sure to ask. All right, here's 9, 10, and 11. On these, I chose to do them in the 2 different colors. So the green is the left side, the pink is the right side, just like from the notes and video from yesterday. So if we take a look at this, we have the equation with the restrictions. I gave you both the interval and the inequality. So take a look at these. Make sure you're using the x value at the vertex here every time, the x value at the vertex, and that you're also making one inclusive and the other not. So one has the bracket or the equal to, the other does not, and it doesn't matter which one. Okay, you could have chosen to do these either way. So you could do it algebraically or by looking at the graph. Okay, and now let's take a look at 12 and 13. We said, take a look, notice which one's the right side, which one's the left side, because the right side, this coefficient goes here. The other thing we said was this x is the x at the vertex, so it's x minus 4 here. Now to find the y, we have to plug that 4 in. So half of 4 is 3. Half of 4 is not 3, it's 2. And 2 minus 1 is 1. Okay, so we got to find the right side on this one. This is the right. So positive 5 is our leading coefficient. This is negative 2, so here we would end up with plus 2. Always do the opposite. And then if we plug in the negative 2, it gives me positive 10 plus 1 is 11. If you have any questions about any of these homework problems, be sure to stop Miss Willoughby and ask. All right, if you did not pick up your worksheet on the way in the door, it is on the bookshelf as you enter the room. You can go grab that now, and you can hit pause until you're ready to start today's notes. All right, today's notes involve more piecewise functions. We're going to look at 2 things today. We're going to look at how to evaluate and how to graph some piecewise functions. Evaluating is pretty simple. For each of these examples we have here, I'm asking you to evaluate it for an x value of negative 3 and an x value of positive 4. So the first thing we have to do is look at our piecewise function and determine where this goes. So if we evaluate this function for a value of -3, which one of those pieces does -3 fall into? Well, it falls into this one, where x is less than 4. -3 is less than 4. So what does it say the y value is? It says it's 10. Okay, now let's do the second one. I'm going to go ahead and change colors. So an x value of 4. So let's evaluate function f for an x value of 4. Now +4 actually fits into this interval where x is greater than or equal to 4. So what is my y value? -1. So you look at your values for which you're evaluating, determine which piece they fall into, plug them in if you can, and evaluate. All right, so let's take a look again. We're doing the same two values. So this time function g, let's evaluate function g when x is -3. So -3 falls into this interval where x values are less than 0 because -3 is less than 0. So this is the equation that we plug -3 into. So 3 times -3 minus 1. 3 times -3 is -9, minus 1 is -10. All right, now let's evaluate g of +4. Okay, it looks like it would fit in here, but there's no equal to, so we got to go down here to the last one, where all of our x's are greater than 4. So if we plug 4 in here, 1 minus 4 is -3. All right, we'll do one more together, and then I'm going to give you a few to try. So on this one, we're still evaluating for the same values, so we'll do -3. -3 falls into this interval. So I'm plugging -3 into this piece of the piecewise function. So it's 2 minus -3, minus a negative makes a positive, and it becomes +5. Now the next value is 4, so this is h of 4. So 4 falls into this interval, so that's what I plug it into. 6 minus 4 is 2. And we keep doing the same process. All right, so let's go back to -3. K of -3. -3 falls into this interval. Now, we did this one to start with. You'll notice on this is like a horizontal line. Y equals -12. And on that horizontal line, no matter what the x value is, y is going to be -12. So there's no place to plug in the -3. That is automatically my y value. All right, let's now evaluate this same function k for an x value of +4. Now this time +4 fits into this one. Might be tricked to do it here, but there's no equal to. So this time we're dealing with the middle function. So 7 times 4 is 28. K of 4 is 28. Okay, let's do one more together, and then we'll let number 6 be your you try. All right, for number 5, when we first evaluate this function f for a value of -3, that's going to fall into this interval, -3. So it gets plugged in. The square root of -3 plus 4 is the square root of 1, and the square root of 1 is 1. Now we're going to do f of +4, which falls into the other interval. And so 4 plus 2 is 6. Number 6 is your you try. So go ahead and hit pause and give number 6 a try. And then when you're ready, press play. Okay, g of -3. -3 falls in this interval. So we'll have to do -3 cubed, which is a -27. Take away one more is -28. And the last is g of 4. And g of 4 falls into this interval. So we'll do 4 minus 3 squared plus 3. 1 squared is 1, and 1 plus 3 is 4. So g of 4 is 4. And that is how you evaluate piecewise functions. Now what we're going to do is graph them. Okay, so we can see, I see this function will consist of 2 pieces. This function will consist of 3 pieces. This function will consist of 3 pieces. And if I look at the pieces, linear, 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 linear. None of those are exciting, but don't worry. We have some excitement on the back where we mix it up. So let's start with some of these. Probably do 1 and 2 with you and give you 3 to try. All right, so we know that this piece is going to start at 0 and go left for x values that are less than 0. So we know it's starting at 0, so to figure out where that is, we take the 0 where it starts and plug it in. Well, 0 times anything is 0. So this one's going to start at 0, 0. But if we look at it, there's no equal to. So when I go to put my first point, it needs to be an open circle. Maybe not that large, but an open circle. So we have an open circle here because there is no equal to. If there were equal to, we'd fill it in. All right, now we look at this, it's a line, so we use slope for a line. And for this one, it's rise over run, up 3, right 2, up 3, right 2. But I can't go that way. It's only for x values that are less than 0. So I have to do the opposite. Down 3, left 2, down 3, left 2. I do get to go forever in that negative direction. So when I go to draw in my line, I'm going to put an arrow at the end because it's all x values less than 0. So it goes on forever. Now this one, 3. 3 really means y equals 3. That's a horizontal line. And it's a horizontal line that's going to start at 0 and it's going to end at 4. 1, 2, 3, 4. Now at 4, instead of a closed circle, it's got to have an open circle because there's no equal to. And then we just connect the dots. The linear ones that have a start and a stop are the easiest because all you have to do is draw your start, draw your stop, and connect the dots. Okay, number 2. This first piece of our piecewise function is a line, and it's a line that has a start and a stop. Easiest. So, to figure out where we start, we plug in that -4. So, an x value of -4, -4 times 2 is 8, -4 times 2 is -8, plus 8 is 0. So this one's going to start with an open circle because there's no equal to at -4, 0. Open circle right there. Now we'll find its stopping point. It's going to stop at, plug in -2. -2 times 2 is 4, plus 8 is positive 4. -2 times 2 is -4, plus 8 is positive 4. So it has a stop at -2, positive 4. And that stop is also going to be an open circle because it is also less than and not less than or equal to. So now we have our 2 points and we connect the dots because this one's linear, it's got that nice, and if we look at it, this has a slope of 2, so does this, up 2 over 1, up 2 over 1, check, we did it. All right, the next one is also a line. It has a start and it has a stop. This start is going to be solid. So if we plug in the -2, the opposite of -2 is positive 2. So this has a solid at -2, positive 2. And then we plug in 0, and the opposite of 0 is still 0. So we have a solid at 0, 0, and we connect the dots. And then we check. Look at this slope, down 1, right 1, down 1, right 1, -1 slope, check, it works. All right, last piece. It has a start, but then it goes forever right. So we have to figure out where it starts. You plug in your 0, you get out -3, and it's no equal to, so it's going to be an open circle down here at 0, -3, and then it goes right forever. So we check out the slope. The slope of this line is positive 1. Going right forever. So up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Right forever. And that's it. And we do need to put the arrow at the end because that one keeps going. And there is our piecewise function. Okay, you try this one. So go ahead and hit pause. If you're not sure what to do at all, this is the time where you ask Miss Willoughby for help. When you're ready, press play. All right, so let's go over this one now. If we plug in the -2, half of -2 is +1, and 1 plus 1 is 2. This is going to be an open circle at -2, 2, and the reason it's open is because there's no equal to. All right, now this one is going left forever. All x values less than or equal to -2. That means left forever. With a slope of -1/2, if we're trying to go left, we can't go down 1, right 2, so we have to go up 1 and left 2, up 1 and left 2. That will give us the negative slope that we need. So you just kind of have to go backwards of what you do in the right direction. All right, the second piece, I'm going to change colors this time. This second piece right here has a start and a stop. So if we plug in -2, we get out 6 minus 1 is 5. So we're going to have a closed circle at 2, 1, 2, 3, 4, 5. That's my start. My stop, I plug in 1 and I get out -4. So I'm going to have a stop at 1, 1, 2, 3, 4. Now that's going to be an open circle because there's no equal to here. And then we will connect the dots. Hold on one second. I put an arrow at the end of that one. I didn't mean to. Okay. So let's get rid of that arrow real quick and we'll connect the dots again. Okay. And that's that middle piece. All right, finally, we'll do this piece. Now this is just that horizontal line, y equals 4. It has no slope. So we're going to start at -4 and +1. Well, look at that. It fills in that point we just did. And then we go forever right. And that's that piecewise graph. All right, we're going to do 2 more together, and then 6 and 7, and the book problems that are at the bottom of the page are your homework. So we're going to do these 2 together, and the rest is for you. Okay, the next problem. You will notice these are not all just lines now. This is a parabola. The vertex of this parabola is at 1, 0, 1, 0. So then I have these moves. 1 squared is 1, 2 squared is 4. Okay, but don't graph all that yet because this is for x values that are less than or equal to 1. So these don't get to play. They don't even count. I can only go this direction. I can only go to the left. So if you need to draw them and then erase them, that's fine. Or if you're fine just never drawing them to start with, that's even better. All right, this second one is a line. But this line is going to start at 1, plug in your 1, 2, 1, 2, 1, 2, open circle. This line gets to go right, and so the slope is +1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And then we'll graph that line, forever right. All right, the last one we're doing together. This one's cool, it's got a square root on it. This square root transitions to the point -4, 0. Okay, this part right here is our restricted value. It kind of runs together, but that's our restriction. So it's going to start at -4, 0. And I do get to do the solid because of the equal to. Moves for square root. Square root of 1 is 1. Square root of 4 is 2, and so forth. So this one would go from here to here. And I got to stop there because it says stop at the 0. Now this one's going to start at 0. So this starting point is 0. Plug in the 0. We get out 2. Open circle because there's no equal to. You can't even tell I did it really. If that was all pencil, you wouldn't even notice. It's there. All right, and this slope is positive 1. So we'll go up 1 over 1, up 1 over 1, forever right. Okay, so because this completely filled in, you can't even tell. There was already something there, so you can't even tell the pink is there. All right, so the next two and the bookwork problems are for homework. Now, what I would like you to do at this point is I would like every single person to go get a book, and I'm going to record your book numbers. You open up your book and write your name on the inside, and then I will come by and record the book number that is on the bind of your book. So you can close it back and I can read your number. All right, if you have questions, be sure to ask.